Today, we're diving into a really revolutionary concept that could completely reshape how we manage networks. It's called the AI Native Control Entry Point, or AICEP. So you have to wonder, right? In this age of AI and incredible automation, why is managing our networks still so, well, clunky, rigid, and slow? This explainer is all about a new architecture designed to tackle that exact problem head-on. The heart of the problem is what we can call the network management bottleneck. See, the very standards that were designed to help everything work together have kind of become a source of friction themselves, a real barrier to moving fast and innovating. We all have this incredible vision, don't we? We dream of zero-touch, totally autonomous networks that just work. But then you look at the reality, and it's a completely different story. We're stuck with these rigid data models, these schemas, that make any kind of evolution painfully slow. There's this huge gap between where we want to be and where we are. And you can see this exact gap baked into the frameworks we use today, like ORAN and ETSI ZSM. They all rely on standardized interfaces. You've probably heard of them: O1, A1, O2. And look, they're great for making sure different vendors can play nice together, but they also create a ton of work and overhead every single time you want to add a new function. It just slows everything down. So what if there was another way? What if we could get that all-important interoperability without all the enforced rigidity? Well, that brings us to a new way of thinking, a solution that, at the control level, is basically standardless. And that solution is AICEP. Now, this isn't just a small tweak, it's a total architectural rethink. Instead of forcing every piece of gear to speak the same super structured language, AICEP uses something called Learn Semantic Translation. Basically, it teaches itself to translate a high-level goal into the specific native commands that each network device understands. And this quote from the source material just nails it. AICP's whole mission is to replace those old-school schema-defined interfaces. This isn't just an upgrade, it's a fundamental move away from rigid, predefined rules to a world of intelligent, adaptive understanding. The easiest way to think about it is like this. AICEP is like a universal translator. Instead of making every network device learn one super complex language, you just give each one its own personal, real-time translator. Okay, so how does this magic translator actually work under the hood? Let's peel back the layers and look at the AI native engine and see how AICEP works with another key piece of the puzzle, GAIAS. So if you look at this diagram, you can see the basic building block. Every network function, or NF, gets a simple single-entry API. When an instruction comes in, the NF doesn't try to figure it out itself. Nope. It just passes the job over to an external AI service called Generative AI as a Service, or GAIAS. And the really important part? The vendor's own native APIs are left completely alone, totally untouched. And these individual pieces, they don't work in isolation. They actually stack up into this really neat three-layer architecture. Up at the top, layer 1, you've got the Service Management and Orchestration, the SMO, which takes in those high-level goals from the operator. In the middle, at layer 2, you have controllers that handle coordination across different clouds and vendors. And then at the bottom, layer 3, you have the individual network functions themselves. Each layer uses the same AICEP pattern, so they can all talk to each other without needing a shared, rigid rulebook between them. The GAIAS engine itself runs on this super deterministic 6-step loop. First, it takes in the intent. Then it does what's called grounded planning, where it actually looks through vendor documents to figure out the best steps. After that, it validates the plan against safety guardrails, executes it using native APIs, checks to make sure everything worked as expected, and finally sends back a confirmation. And to show you how simple this can be, the prototype was tested with just a plain English command: deploy a web server. That's it. No complicated code, no massive configuration files, just a simple instruction. And the results? Honestly, they're pretty mind-blowing. That simple command went from an idea to a fully provisioned live web server on Amazon Web Services in less than 60 seconds. This proves the whole concept isn't just theory, it actually works, and it's incredibly fast. This kind of performance immediately brings up a couple of huge questions, right? First, what's the actual business value? And second, just as important, how on earth can we trust in AI with our critical network infrastructure? So let's talk about value, trust, and safety. Let's talk about the business case, because it's pretty compelling. ICP slashes the effort it takes to bring new gear online because you're not messing with schemas. It lets vendors keep their own APIs, which they love, and it lets you roll out new services way faster. All of this means lower operating costs and a much quicker time to market. Okay, now for the big one, safety. And let's be really clear here. This is not about just letting some unconstrained language model go wild on your network. AICP uses a technique called guarded configuration synthesis. The AI has to operate within very strict, predefined safety rules. It keeps it from doing anything unpredictable, which is something you worry about with other AI tools. And on top of that, for total transparency, everything gets logged. We're talking the initial intent, the plan the AI came up with, every single API call it made, and the final verification results. This gives you a complete audit trail, which is absolutely critical for traceability and compliance. So, AICEP isn't just about fixing today's problems. It's really a blueprint for the future of network orchestration, especially as we start thinking about what 6G is going to look like. This timeline really maps out the journey. We start here, today, with our legacy, standards-bound systems. But pretty soon, we can start rolling out AICP bit by bit. Down the road, you can imagine smaller, specialized AI models at the edge handling routine stuff. And eventually, we get to a future where standards aren't about rigid interfaces anymore. Instead, they're about defining contracts for performance and observability. It's a completely AI-native world. And all of this brings us back to one huge, provocative question. If an AI can act as a universal translator, one that's faster, more flexible, and way more efficient, then are the rigid, slow-moving standards that have defined networking for decades, well, are they obsolete? That's the fundamental question that AICEP really forces us to think about.